The question is, we have a series given, the power series format. An here is n by n plus 1 times x to the power n. We need to find radius of convergence and interval of convergence. So we are going to use ratio test here. I want to point out that here we are not saying that we are finding is it convergence and divergence. We are trying to find for what values of x this converges. We already want it to converge. Okay, we just want to figure out where, at what values of x this converges. So I find the ratio test. Limit n approaches to infinity. An plus 1 is, let's try to write an plus 1 here. Change n to n plus 1 everywhere, n plus 1 and times x to the power n plus 1. You guys notice n plus 1 is actually going to become n plus 2. So here is an plus 1, n plus 1 by n plus 2 times x to the power n plus 1 divided by n by n plus 1 times x to the power n. X to the power n factors with x to the power n plus 1 factor, only x will left. And we don't know the sign of x, so x has to become in the absolute value. And the remaining what we have, n plus 1 by n plus 2 times n plus 1 by n. The denominator fraction flips and multiplies. Okay, so we have these two fractions here. We can write it as n plus 1 whole square divided by n squared plus 2n times absolute value of x. So notice what is the highest power of n in the denominator is n square. So I'm going to divide everywhere in the denominator by n square and everywhere in the numerator by n square. But it's a square when it goes inside, it's going to look like n only. It is dividing by n square though, because outside is square. So what do we have? Limit n approaches to infinity. 1 plus 1 by n whole square by 1 plus 2 by n times absolute value of x. When n is approaching to infinity, 2 by n is going to approach to 0 and 1 by n is also going to approach to 0. So what do we have left? 1 times 1 absolute value of x, just absolute value of x. Now, where did we start from? Ratio test. Ratio test claims the series converges if the limit is less than 1. So, the given series converges if absolute value of x is less than 1. Therefore, radius of convergence is equal to 1, this number. Okay. And for the interval of convergence, we get absolute value of x is less than 1, meaning what? X is between -1 and 1. So that is -1 to 1. Now we notice that this is interval of convergence, but we need to check on the endpoints. We are not confirmed about what is going to happen on the endpoints. Okay. So what I'm saying is now you need to check what happens at x equal to -1 and what happens at x equal to 1, because that ratio test is not giving to us. So I'm going to check what happens when the x is less equal to -1. So my series is, I'm just going to copy my series here, n by n plus 1 times, in place of x I'm going to write -1 the power n, because x is -1. Okay, this becomes an alternate series. So if you want to use alternate series test, bn would be n by n plus 1. Limit of bn would be coming as 1, right? If you divide by n everywhere. That means AST test fails. So, but limit of n approaches to infinity, n by n plus 1 times -1 by n also does not exist. Therefore, using divergence test, this series diverges. So -1 is not included basically. Similarly, if you check at 1, let's try again. Write the whole series. In place of x, now we are putting 1. 1 the power n is just 1. So that is n by n plus 1. If you find the limit n approaches to infinity of n by n plus 1, that's also 1, not equal to 0. So again, using divergence test, this series diverges. Therefore, x1 is also not included. So what we are claiming is interval of convergence is just -1 to 1. Endpoints are not included. Okay. So how do you start? You start by finding the radius of convergence using the ratio test. We found that the series is convergent if absolute value of x is less than 1. That gives me the radius of convergence and interval of convergence. At the endpoints, you need to separately check. I did check, but both the endpoints, the series is coming to be divergent. So endpoints are not included.